The building that killed 98 people in Surfside, Florida, didn't look like it was failing. Champlain Towers South stood for 40 years. In 2018, engineers documented significant cracking and deterioration in its concrete structure. The repairs never happened. On June 24, 2021, it collapsed without warning. But this is not just one building's story. Roughly 40% of America's buildings were constructed before 1970. Many have now passed a threshold most people have never heard of, something engineers call design life. And what that means may be the hidden crisis no one is watching closely enough to see. In structural engineering, every project begins with a baseline calculation, the design life. This represents the planned timeframe in which a structure is expected to perform its intended functions safely and reliably, without requiring major, unplanned intervention. This number serves as an engineering assumption during the blueprint phase, rather than a legal occupancy limit or a countdown to automatic failure. When engineers specify materials and structural margins, they build around these distinct horizons. In the United States, residential buildings are typically designed for 50 to 80 years. Commercial and institutional facilities, such as office parks and schools, generally target a lifespan of approximately 50 years. Bridges are designed for 50 to 75 years. A major segment of the American transportation network relies on highway bridges built during the post-war construction boom between 1950 and 1970. These structures were built under the assumption that routine maintenance would sustain them through their planned operational lifespan. But when a structure quietly passes this calculated threshold, its actual performance begins to diverge from its original design. Crossing the design life horizon does not mean a building will suddenly collapse. Instead, it marks a transition into a period of escalating maintenance costs and unpredictable structural behavior. Standard wear begins to turn into systemic vulnerability as individual components fail with greater frequency. When a structure reaches 150% of its design life, its remaining strength becomes non-linear and difficult to model. The structure is not automatically twice as risky as it was at its design horizon, but its physical condition becomes exponentially more unpredictable, and the safety margins engineered decades prior begin to erode. Much of this decay is hidden from view. Inside reinforced concrete, atmospheric carbon dioxide slowly reacts with calcium hydroxide, lowering the material's pH in a process called carbonation. This neutralizes the highly alkaline environment that naturally shields reinforcing steel. Once moisture and oxygen penetrate this compromised barrier, the steel oxidizes and expands. The resulting internal pressure cracks the concrete from the inside out, leading to flaking and breaking away, a failure known as spalling. Similarly, in timber structures, fungal decay quietly consumes wood fibers once internal moisture levels exceed 25%, rotting critical supports behind finished walls. Because these degradation mechanisms occur entirely within the structural frame, a building can look perfectly sound from the street, even while its primary load-bearing elements have been compromised for years. Approximately 40% of all buildings currently standing in the United States were constructed before 1970. This represents a vast national inventory of structures that have already crossed the 50-year threshold, operating past the time frame their original designers anticipated for reliable performance without major structural intervention. In older northeastern cities, this legacy footprint is even more concentrated. In New York, Boston, and Philadelphia, the share of buildings constructed before 1970 exceeds 60% of the total building stock. These structures are defined by the structural engineering assumptions of their construction era, rather than their current physical condition. Before 1970, municipal building codes relied primarily on gravity load designs and had only modest requirements for lateral forces. They predated the comprehensive seismic, high wind, and load path standards that govern modern engineering today. Because of this, millions of occupied residential and commercial square feet lack modern structural ductility, automatic fire sprinkler systems, accessibility standards, and energy efficiency envelopes. When a building owner faces the necessity of major structural rehabilitation, the financial calculations change dramatically. Structural retrofits can add 15 to 25% to a baseline construction budget. Bringing a concrete high-rise built before 1970 fully up to modern seismic and fire safety codes can cost up to twice as much as demolishing the structure and rebuilding it from the ground up. Because of these prohibitive costs, older buildings often remain in active service with minimal structural intervention, keeping their outdated design assumptions permanently cast in concrete and steel. Using a building's construction era to analyze systemic risk does not mean every older structure is unstable or destined for failure. Instead, the year of construction identifies the baseline rules and engineering limits under which the building was permitted to exist. When those outdated baseline codes are combined with decades of slow, uninspected material decay, the safety margins engineered into the mid-20th century quietly begin to erode, leaving millions of structures highly vulnerable. In Surfside, Florida, a 12-story residential condominium completed in 1981 became the central case file for this accumulating risk. Champlain Towers South stood for 40 years on the edge of the Atlantic Ocean. At 1:22 a.m. on June 24, 2021, a major portion of the structure collapsed without warning. The failure killed 98 people, becoming the deadliest unintentional building collapse in American history. 3 years before the disaster, in October 2018, Morabito Consultants conducted a structural field survey of the property. The engineering firm documented significant cracking and spalling in the concrete columns and the pool deck slab. These load-bearing elements, exposed to coastal air, had begun to show visible signs of distress. In the final minutes before the collapse, the physical reality of this deterioration became apparent. John Miller, a resident on the 12th floor, woke to the sound of a loud cracking noise and felt the high-rise sway. He managed to escape down the fire exit as the concrete deck gave way. Within moments, decades of slow, uninspected material decay resulted in a sudden redistribution of weight, tearing the eastern section of the building down to its foundation. The structural warning signs documented in 2018 carried an immediate financial barrier, an estimated $9 to $15 million in required repairs. For the Champlain Towers South Condominium Association, this massive estimate triggered years of internal debate over how to fund the work. While residents negotiated over individual assessments, the Capital Repair Fund remained dry, leaving the structural vulnerabilities unaddressed. Below the surface, the physical decay escalated. The National Institute of Standards and Technology later confirmed that the lowest level of the parking garage had sat in pooled water for years. This standing water seeped through microcracks in the concrete, contacting the internal steel reinforcing bars. Once moisture and chlorides bypassed the protective concrete cover, they initiated a destructive chemical cycle. The expanding rust built immense internal pressure, cracking the concrete from the inside out and severing the bond between the steel and the slab. This deterioration had advanced far beyond what routine visual inspections could capture. The final collapse occurred without any external trigger. No hurricane, earthquake, or ship strike initiated the failure. Instead, decades of water ingress and corrosion eroded the building's structural safety margins until the concrete simply could no longer hold. This collision between mounting repair costs and deferred action is not an isolated coastal issue. The exact same funding dilemmas and accumulating material decay are currently playing out in public infrastructure across the United States, placing critical institutions, from public schools to community hospitals, on a similar collision course with their own design life limits. In the United States, an estimated 53 million children attend classes in public school buildings that require significant repair or replacement. According to a 2020 Government Accountability Office report, the average American public school building is 44 years old, with 41% of all school districts needing to replace or renovate major building systems. This has left municipal school boards facing a combined deferred maintenance backlog of $85 billion. This financial burden is not shared equally across communities. Public school facilities in lower-income districts average 10 to 15 years older than those located in wealthier neighborhoods. For these older facilities, structural decay rarely manifests as a sudden, catastrophic collapse. Instead, the crisis is experienced as daily disruption, lost instructional time, emergency relocations, and failed heating systems. In 2026, an Atlanta middle school suffered an infrastructure failure when a 1972-era cast-iron waste pipe burst, flooding the library and forcing an 11-day closure for 840 students. Facilities directors must constantly choose how to ration limited capital, balancing the immediate needs of leaking roofs, failing boilers, outdated electrical grids, and corroded plumbing. While these persistent failures expose a systemic national funding gap, they do not prove that every older school is structurally unsafe. They do, however, show how deferred maintenance quietly erodes the functional life of the spaces where children learn. Acute care hospitals in the United States average 40 years of age, with a large portion of this footprint tracing its origins to the post-World War II Hill-Burton Act. These facilities were engineered around mid-20th century healthcare demands, and many now operate past their planned design horizons. Hospitals cannot easily shut down for emergency repairs. Continuous operation is mandatory, turning aging infrastructure into a constant risk to patient care. The American Society for Healthcare Engineering and the Joint Commission consistently identify building infrastructure as a primary compliance risk. When a 40-year-old ventilation system fails, the consequences are immediate. A loss of air pressure control can compromise sterile operating rooms, disrupt negative pressure isolation zones designed for infectious diseases, and introduce airborne pathogens. In 2022, an HVAC chiller failure at St. Mary's Hospital in Florida forced surgeons to cancel elective procedures due to corroded condenser coils in a 1975-era system. Plumbing and electrical failures carry similar operational threats, occasionally forcing facilities to divert emergency patients or scramble to maintain backup power. When these legacy systems break down, they cause sudden, quiet halts to patient care. While slow environmental degradation weakens structures day by day, an entirely different threat waits in the earth. Across the American West Coast, thousands of buildings constructed before modern seismic codes stand in active earthquake zones. California contains over 15,000 concrete buildings built before 1980 and classified as high collapse risks. These structures lack the ductile reinforcing steel required to bend during ground shaking, making them highly susceptible to sudden, brittle collapse. Many are soft-story buildings, featuring open parking or retail spaces on the ground floor. During an earthquake, these weak lower levels can easily pancake under the weight of the upper floors, trapping occupants inside. In 2015, Los Angeles passed a mandatory seismic retrofit ordinance targeting these non-ductile concrete and soft-story structures. However, the law highlights the immense scale of physical and financial mobilization required, granting building owners a 25-year compliance window that extends to 2040. For property owners, the primary obstacle is financing. Seismic retrofits can easily cost $80,000 or more. Many building owners struggle to secure this capital, facing a difficult choice between taking on high-interest debt or risking city citations and potential building closure. Further north, the risk is compounded by time. The Cascadia subduction zone has a known megathrust earthquake recurrence interval of 200 to 500 years, a cycle described by geologists as overdue. The last major magnitude 9 event occurred on January 26, 1700, placing the region well within the historical window for another massive rupture. Yet, in the Seattle and Portland corridors, between 3,000 and 4,000 unreinforced masonry and soft-story buildings remain entirely unbraced. In these cities, decades of slow material decay combine with acute seismic exposure, leaving thousands of occupied spaces vulnerable to sudden structural failure. Under the Federal Highway Administration's National Bridge Inspection Standards, every highway bridge in the United States must undergo a structural inspection at least once every 24 months. This federally organized framework ensures that environmental wear is documented systematically. For occupied commercial and residential buildings, no such national safety net exists. Instead, the rules governing where people live and work are fragmented across thousands of local jurisdictions. Before the Champlain Towers disaster, Florida was one of the few states with any structural oversight, requiring a milestone inspection at 40 years and every 10 years afterward. After the collapse, the state tightened this law, mandating inspections at 30 years for buildings within 3 miles of the coast. Yet Florida remains an outlier. Most states still have no mandatory structural inspection requirements for occupied buildings at any age, meaning most occupied buildings have never received a comprehensive structural inspection since construction. This regulatory gap is often obscured by a confusion of terms. A standard permit inspection, fire inspection, home inspection, and reserve study are entirely different from a comprehensive structural assessment. Instead of a single line of defense, responsibility is distributed among owners, homeowners associations, engineers, municipalities, states, insurers, and tenants. Without clear, unified mandates, the system defaults to a dangerous status quo. Treating a building as safe because it is still standing is an assumption, not an engineering principle. The body of evidence leads back to a fundamental failure of oversight. The question is not whether buildings like these are failing right now, it is whether anyone is looking. To follow more in-depth investigations into the hidden crises shaping our world, subscribe to our channel. We spend our lives inside structures defined by invisible engineering horizons, assuming safety is guaranteed by default. But as design lives expire, that assumption becomes a quiet gamble. The danger isn't just that our buildings are aging, it is that we continue to look away, waiting for the next failure to force our eyes open.